Okay, alrighty, so we're going to start the slideshow now. I'm David Hilstrom with my dad here. You can see the audience here. Yeah, even the dog's doing it. So we're going to give you a presentation about our book. We're trying to make it so we're going to tell you the story of why we wrote the book instead of telling you about all the physics or all the science. And we don't have pretty much any equations in our book or our theory. So we're going to tell you the story about why we wrote the book and a little bit about what the book is about. So that's what this is going to be now. Okay, folks, so they're seeing it. So we're going to tell you the story about why this book was written. And the story starts with the Brazilian flag, açaí, which is a Brazilian fruit that's related to the cocoa bean, and my art there. So let's tell the story. And I didn't get the permission from Doris, so I'll get in trouble later. So it started in 1992. That's a picture of Doris in 1992. And we had she was making her clothes in Long Beach. And it had all of her clothes in there, but it also had my art. This picture doesn't have my art in it. So Long Beach, California. And what happened was she had outside American flag and a Brazilian flag. And what happened was somebody came in and saw the Brazilian flag, and they had this conversation. He says, "Are you Brazilian?" She said, "Yes, I am." He says, "I have this idea of importing açaí to the United States." And so did a million other people. And she goes, "That's nice." And he goes, blah, 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 blah. He talks about it, and she pretends to be interested in the guy. So then all of a sudden he says, "Oh, nice art. All the art you see here is mine." And she goes, "Who's the artist?" He said, "Who's the artist?" And she said, "Oh, that's my husband." And she goes, "Your husband's an artist?" She says, "Well, no, he's a scientist and an artist." "Wow, he must be a big thinker. He could help me with my father-in-law get the word out about his physics theory." So she said, "Okay." And I remember her telling us, "There's going to be this physics guy coming to the store. He wants to talk to you." And I go, "Thanks, dear." So it turns out that I met this guy, Dr. Ricardo Carazani. That's a picture of him. Actually, it was taken by a picture of I took him to a studio, and he was taken by a very famous photographer who took all the biggest musicians in the early 20th century whose works are in the Smithsonian. And I said, I learned about this man, and he said, "Einstein is wrong. Here, read these," and you can see that's not me at the bottom, but that's what happened. He gave me a stack of papers to read. So I met this really interesting man, and he said, "Einstein wrong." So I started to look into this, and in 1996, that's me up there in the Grand Canyon, and I ended up meeting all these scientists around the world who said they knew Einstein was wrong, Big Bang was wrong, a lot of these things, big critical thinkers, big thinkers. And so I got to know these people. Well, it turns out that I said, no one's helping these people, so my friend there, that's the guy who was working actually in a software company, a poker-playing software company, and he said, "Dave, quit complaining, why don't you make a film?" And so I said, "No one's paying attention," he said, and I said, "Okay." So I decided I'd make a film to get the idea of all these scientists who knows Einstein's wrong. I said, "Hey, Dad, I want to do this film, and I want to do an experiment in this film. Will you help?" And he goes, "Yes, I can." In fact, that picture is from our documentary film, and for the experiment down at the bottom with a bunch of lead, and that's my dad up there pretending to be smart and have all these very important equations. So in 2007, he comes up with this equation, which you don't need to see, understand at all, but basically he made gravity, a bunch of those, you see on the screen there, a bunch of little dots going in all directions. Gravity is actually a particle that's pushing everything down. So he made this equation for the particle, for a model, and you can see my mom, who was there, is sleeping. So I said, and then my dad says, "I'm done," and I said, "No, my film isn't finished." And I got all upset and worried, and that's me filming, and I didn't know what to do. So in 2007, I come back a couple months later, and I said, "Dad, you're still working on this. And he goes, I know. And I said, well, why are you working on it? He says, well, the two lines there, you don't have to be a mathematician or know what that means. But one line is from Newton, and the other line is from my dad's equation. He says, how could me adding up all these little gravity particles hitting the Earth end up being the same as Newton? That's just too bizarre. So he kept on going. And then, move ahead in 2015, there's Robert Berger. Where are you, Robert? There he is. We had a meeting at my house, not my house, my dad's house, and he was talking about gravity. My mom was there, Robert was there, and I was there. And my dad put up this diagram with dots. 1, 2, 4, 5, 4, 2, 1. And he goes, that's what light is. And I didn't understand it. And then I did, and I went nuts, because I realized my dad had solved one of the biggest physics problems in history, which is whether light is a particle, a photon, or whether light is a wave. Is it a wave, or is it a particle? And he solved what's called the wave-particle duality. I went nuts. He didn't believe me. He came to me 3 weeks later, knocked on my door and says, hey, Dave, I think I solved the wave-particle duality. So all it means, again, is he can describe what light is. No one really has been able to do that. So we ended up, I said, we got to write a book, because over the years I had collected all these great ideas, but I didn't have any idea for light. So I said, we're going to start writing this book, and that's what you see here today. The universe is not magic. It's really easy to understand, actually. And the name of it's Principia Mathematica 2. What the heck is that? Who cares? Why you named something stupid? Well, the real title is at the top, which is the universe is not magic. All the forces that we see are not magic. Science still has no clue as to what light is, what gravity, any of these things are. For instance, you take a magnet and you ask a science teacher to say, what is the magnetic field? Why do the magnets come together? No, everyone will tell you it's a magnetic field. Then you ask them, what's the magnetic field? And what do they say, Robert?
I don't know.
That's right, they don't know. So as much as we think science is super advanced, we don't even know what a magnetic field is. We use magnets everywhere. You couldn't have your phone, you couldn't have electric cars, you couldn't have almost anything without magnets. So we don't know what that is. Gravity, it attracts, right? What is it? We don't know. Einstein says it's space-time bending. That's a bunch of baloney. Space can't bend. What's time doing in there? It doesn't make sense. We don't know what gravity is. That's the truth. Electricity. Everybody thinks we know what electricity is. If you ask your teacher, how fast does the electron go through a wire? They're going to say a couple of meters a second. That's impossible. We know that electricity goes pretty much close to the speed of light. Yet they say it goes meters a second. They don't know what's going on yet. They don't know. Light, it's a wave, it's a particle. What is it? They don't know again. And that's what my dad came up with one answer. So, our book, what are these things really? What is light? What is gravity? What is electricity? There's no equations. There's zero equations. We wanted to know, what is it physically? We do not believe, my father and many other people believe, that the universe is not magic, that all forces are caused by something. Yes, we can't see them. Just when if I blow air into your face, you feel it. Do you see it? No. We know things are there, but we can't see them. So our book was written to really describe these things. Why did we call Principia Mathematica? Because Newton, the guy who discovered gravity more or less, whose apple's falling on his head, and that's an actual picture of the apple tree where he learned about gravity. He called this thing called Mathematical Principles of Physics. He wrote it in all Latin. It's a terribly written book, actually. You can hardly understand it, but it's all in Latin. So that's why we called it Principia Mathematica, our book. His equations allow us to build buildings. It allows us to go in space. His gravity equations are used by NASA and SpaceX and everybody else, and they're very, very useful. There's only one problem, and that is he didn't tell us what this stuff was. In fact, he was a very good scientist, and he told the world, you can't and don't ever accuse me to tell you what I think of gravity really is. All we do is have equations for light, gravity, magnetism, electricity, but we don't know what it is. So that's why we use the Principia Mathematica 2. That is my father's model for light, and other models we've collected as well are now all put together, and our book is going to tell you what those things are. If this is true, it's the first time in 400 years. So you're either sitting with two crazy scientists who are doing stuff that no one's going to care about, or this stuff could be really something else. So this is it. This is what we discovered. All of the entire book is about this. That is, what makes gravity, what makes electricity, what makes magnetism, and what makes light is simply the way particles move. So particles, if they move all flowing together, it's electricity. If they move in random directions through space, it creates gravity. And we'll show you how that works. And magnetism is simply these things going in a loop. And that makes sense because you've got this magnet there and you see these lines there. The particles are literally looping around. And that's why you have a north and a south. So we're going to talk a little bit about that. That's what our book is about. So what is gravity? It is particles going in random directions. That is, gravity is not magical. There are particles that cause gravity. They call them the graviton. If you ask a teacher, well, if you think I'm a physicist who got a Nobel Prize, I think gravity is a particle, and they'll call it the graviton. So that's what, and that actually is from 1690 and 1740. This is not our idea. So we took this idea, we put it together with this idea from a friend of mine. His name is Jonel Deneau from, and he found out in his little girl's plastic pool. He has a little pool in his house. He found out that magnetism were flowing particles that go round and round. And I will show you his video of this. So here's this kid's pool. He puts two cylinders in the water, and when he spins them in the same direction, they go apart. When he spins them in the different directions, like this, they come together. They work exactly like magnets. So let's take a look at it.
Electric motors. The electric motors will be driven by a common 12 volts car battery. In one case, the motors will rotate in opposite directions. Therefore, the cylinders will rotate in opposite directions in water. In another case, the motors will rotate in the same directions. Therefore, the cylinders will rotate in the same directions in water. In this experiment, we're going to start the motors, which are going to rotate the cylinders in opposite directions. Let's see what happens. We start the motors now.
So the water's flowing around them, and they create these water flows around them. Watch what happens.
We see that the cylinders attract each other and now are sticking to each other. Let's try to separate them.
Looks just like magnets. It's amazing. When I saw this, it blew my mind. 2006.
It's pretty far apart.
Yeah.
We see them attracting each other again and sticking to each other. Let's stop the motors. We observe that the cylinders are coming back to their original positions. Now let's start the motors again. We observe that they attract each other again and stick to each other now. We stop the motors now and conclude that cylinders rotating in opposite directions, submerged in water, attract each other. In this experiment, we're going to rotate the cylinders in the same direction and see what happens. Let's start the motors now. observe that the cylinders repel each other, their relative distance is increasing. Let's try to push them against each other, see if we can reduce the distance, and what happens if we reduce the distance? It's quite difficult to make them
Just like magnets.
approach each
Exactly
other.
like
We see that there is a force which is acting so that they...
Okay? So, if you take that idea that flowing particles in the same direction, they attract, make things attract, flowing particles in opposite directions, they're coming around like this, right? Smack, smack, they hit each other, they separate. Now we have a model for flowing particles for magnetism. Electricity, what is it? It's simply particles flowing in one direction. That's it. This is something I came up with for the model. Actually came from a guy who had an ether model, don't want to get into that. But that's electricity. It's basically particles flowing in a direction. We control it. That's what we do. Okay? Last one is what my dad discovered, and really what made me get us together, write this, and that is, this is what light is. Now let's take a look at it. I got some really good ideas. What is light? Light are particles coming at you in waves, not one particle. The problem with physics, if you ask your physics teacher in your class, they're going to say, light is a photon, one photon. How can a photon give you frequency? What's frequency? It's something that comes every so often. It's a frequency. You can't have one particle create light. So, my dad's idea is that light are waves of particles. These bombers come in every minute. That's a frequency. Light comes in frequencies. Red's faster frequency. Light, or which one is it? Red's slower. Red's slower frequency. Blue's faster. That's what light is. All it is, when we see stuff and it's red, we have particles coming and hitting our, like this. And if you want a really good analogy, just take your hand, put it on somebody's shoulder, press on them. That's what gravity is. Particles is pushing you down. What is light? Well, you hit a frequency. If you turn on your water massage, you now have particles coming at you in a frequency, hitting you in a frequency. It's light. The only difference between gravity and light is that light's coming to you in waves. That's it. So that's what it's about. So this is the big thing. This is one of the things I came up with our model, and that is light, and gravity, and magnetism, electricity. That means the electron, the gravitron, the photon. There is no particle magnet, but the magneton, what do you want to call it? They're all the same thing. How can they be the same thing? Well, the question is, how could different particles travel at the speed of light? That is, we know that light travels at the speed of light. We know gravity travels at the speed of light. We know electricity travels at the speed of light. And we know magnetism travels at the speed of light because we accelerate particles in our particle smashers to the speed of light using what? Magnets. So we conclude that if a particle travels, all those particles travel at the speed of light, they must be the same. There we go. A solar eclipse, the light and gravity arrive at the same time. Our gravimeters and light from the solar eclipse arrive at the same time. A particle accelerator uses magnetic fields to accelerate particles like an electron or proton to the speed of light. It's going at the speed of light, and electricity is at the speed of light. Well, if you've got a particle in the universe, and it travels at the same speed, how can you have different particles? It's the same particle. And does this make sense? Is this possible? Can the universe actually function that way? Well, we think so. We call it a G1 particle for now. G is because it's for gravity. 1 is because we are at this level of the universe. Gravity can be made from giant gravity can be made of stars. Smaller gravity, gravity makes electrons go around neutrons, but we call it the G1 particle. It's the particle for light and gravity, magnetism, and electricity. It's all the same particle. That's it. So the same particle is gravity. They're just going in different directions. Well, how does that create gravity? Well, if you put the Earth out there and the Moon out there, and you have all these particles coming randomly from the universe all around, and they hit the two things, what's going to happen? Well, you're going to get fewer hits there. A particle coming from this side over here isn't going to make it over there. So you see in this drawing here that there are fewer particles hitting in the middle. What does that mean? It's going to make the two move together. The little pushes on each side are going to make those two bodies go together. That's called the shadowing effect. It also works for orbits. So this is not something we came up with. This is 400 years old. This is not ours. So the intuition you need for our model is this. We know that things fall to the ground. We know if you take an apple and throw it to me, it's going to curve. We all know that. We know gravity causes things to curve. We also know if I threw it super, super fast, it would go in orbit around the Earth. And if I even threw it even further, it would go off the Earth, go around the moon, and go somewhere. Our model works that way. Everything in the universe works that way. It doesn't only work at that way, it works at the atomic level. Here's on one side, you have the right side, and the red particles there are the G1 particles. That's what keeps our planet around the sun and comets going in orbit. If you go down to the atom, think of the nucleus as the sun, you have a G1 particle. Well, the G1 particle can't keep itself in orbit. That doesn't make sense. So what has to happen? Well, there's another particle, even faster and smaller. The rule in our model is this. If you see something even at the atomic level making an orbit, it's a bunch of little particles going in random directions causing a gravitational field. So you have two different, let me give you another picture so it's easier to see. There's the G1 particles, which are larger and slower, not slower. And G2 particles, which are smaller and faster at the level down. So the way the universe works, if we have something in orbit around something, there's a small particle below that going in random directions, and that causes those things to orbit. So, and how do we think we know this? Well, if you take a look at the equations for gravity, you don't have to know anything about them. If you look at those two equations, F equals G M1, M2 over R squared, the other one's F equals K times Q1, Q2 over R squared. They look the same. They're just different letters. One's for the Coulomb's atom equation, which looks like gravity to us, and ours is the gravity. So what we say in our model says, no, it's not Coulomb's law, which is magic, of course, and gravity is magic, as Newton says. We just say, it's just gravity again. It's just a different, smaller, faster particle at a different level of the universe. It's the same idea. So the idea of particles going in all directions, causing gravity, keeps the sun going around the Milky Way, the Earth going around the sun, the moon going around the Earth, and what keeps electrons going around atoms is another gravity, but it's a smaller particle. It's a G2 particle. It's a different particle at a different level. And that's one of the things. The equations we came up with without any idea what it was look the same. So they must be the same. And so why do we have this logo for us? It's because the reasons. Gravity 1, which is our gravity, which is G1 particles, and gravity 2, which we discovered or say that happens in atoms. There's a gravity 3, gravity 4, infinitely down. It goes all the way down. And then, of course, we also have our book Principia, 1 by Newton, and our book Principia, 2 by us. And of course, people say that's not very good of you because you're comparing yourself to a very famous person. He said, no, we're just helping out and telling what people it is. So we're almost done here. We are done, and we have 2 books. Unfortunately, the books that we have coming out is already on Amazon. You can buy, but my father and I can purchase them a little cheaper, and we have 40 of them coming, and they were supposed to be here today. But with COVID, they didn't make it. We have 2 books here, and the 2 books we're going to give away today. And so we're going to have people use these ideas on a sheet of paper, and we're going to have you do something. It's so easy that you can hack the universe. So what you have is, this is the thing. If I say, oh, there's electricity going through a wire, you draw these little particles. See the particle up the top? It says, drawing of G1 particles at a head and a tail. So you draw the head and the tail. That's the direction's going that way. It's sort of like a comet, right? With the tail. So if I say there's electricity, well, you draw a bunch of little things there. If it's light coming from the iPhone, you draw groups of particles going up to your eye. If there's gravity pushing it down, you draw random particles. If there's electricity being held in atoms, you have them going around the atoms, and you use those things, and if there's a magnetic field, which there is with wireless charging, then you can do that. So we have sheets over there for those who want to try. You just go and with a pencil, you'll draw them, and I'll show you, it's easy. Put your name, phone number. You get a free viewing of our Einstein Wrong movie if you've never seen it. It was made, took us 8 years to make. It's really good. We have music by Michael Ruggieri. Is he here? There he is. So everybody's watching my film maybe a couple hundred times a year. It's online, people didn't want it because they're afraid Einstein's Wrong is funny. But I asked them, do you like the movie? Yeah, it was great, but the music was fantastic. So if you don't even, it's a really fun story. It's not scientific. There are no equations, very few. At least it's about the story. You'll see Doris in it. You'll see Luanda being born. You'll see my dad going through chemotherapy. It's a very touching story. You should watch it. I had very good editors from Hollywood help me out to do it. So you get to do it for free. Just follow this on the sheet. And what is your homework assignment? It's so easy. Here's what I thought. This is really interesting. You have your iPhone, you have your phones, whatever phone you have. You plug it in, and gravity's pushing it down. You can sort of see the answers already on my slide. You got to think. So the object is to go on the other side and draw the little particles in, because it's actually a white sheet. I should have gotten rid of all those particles. So you have to draw in, number one, gravity pushing the iPhone down. You got to draw those in. Next, you have to draw electricity going through that wire. And then you have to draw electricity stored in the battery. Well, if you remember, in our things, you have atoms storing. Well, I'm telling you answers. You know what the answers are, so you can draw those in. Then we have something even more interesting. And this is where science falls apart, and I thought this is such a great example. People, you take your phone, you set it on a wireless charger. What's happening? You have electricity below it, and you're getting electricity going through the air. How in the heck does that work? And gets into your phone. If you ask a person from science, they say this: the wires have electrons going around. That makes a magnetic field. How does that do that? I don't know. It just makes a magnetic field. How does it do it? I don't know. Then they say, when you do that and you bring another coil close to it, in the magnetic field, somehow they say this word, electricity is induced, which is a magical word. And when they go, what's induced mean? I don't know, it just happens. So the problem with mainstream science is we don't know how electricity gets from here to here. All we know is it moves them around. Well, if it just moves them around in your phone, how is it going to fill up with more? That doesn't make any sense. With our model, we know why, because it's the same particle. Electricity is the same as magnetic field, is the same as light, is the same particles that are being stored in the battery. We're just pushing it, just like water. Water goes here, creates the magnetic field. You get your phone close to it, the magnetic field goes up in the wires, gets in the wires, and it fills into your battery and the atoms. And then it comes out in light. And you can draw in how the light waves come. Where does that come from? You know what the mainstream science says? Electrons, they trigger and release a photon. From where? They don't even know if it's a wave. They don't know what about it. So in our model, it's the same particle. It's just being pushed around. And with your pencil, you can do it. So that's all for our talk. We have those on the desk there with a pencil. You can erase it. If you put your name on it, we have 2 books tonight. The people who do the best on it, we will put those in a pile. We'll choose them. And you get to take 2 books home tonight. We have our books for sale. We'd like you to buy them because we're buying 40 of them. So we are coming. We're going to come to your door if you live here. We will come to your door, we'll have them signed and delivered. My dad is an expert driver because he worked at Enterprise, so he and I will be delivering them. So please support us. You can, if you haven't bought a book, you can buy it online with your phone. I can show you how to do that, or you can give cash. Just put your name there. We also have our T-shirts, and if you look at our T-shirts, it tells the whole model. There's light, which are waves of particles, electricity, which are just particles in the same direction, magnetism, particles going in circles, and gravity going in all directions. So, is understandable at least?
Yes.
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 Well, listen, thank you so much. Again, we have our table there. We have shirts for 15 or hats for 15. And please do buy it. You can buy it online. It's sold. It's now being on sale worldwide. And but if you buy it 35 there, you don't get it signed. We don't. We get $2, I think, because we wanted to make it cheap. It's a 250-page color book, which is pretty expensive to do. We decided to not sell it expensive, 35. We don't care. You know, if this is right, who cares? I mean, the book. You know, that book's going to be of less consequence. But if you buy them from us, because we bought 40 of them, then you can, we'll get them to you next week. I apologize they're not here, but COVID didn't get them here in time. Okay? Thank you. See, it wasn't that bad, was it? Yeah. All right. So what do you guys think?
I love it.
Yeah.
I'll take a few more lessons for me.
I'll tell you tomorrow.
Okay.
Okay, I'll tell you tomorrow.
Okay.
But